Bismillahirrahmanirrahim. We discussed all about the non-inverting voltage amplifiers. Now we will discuss about the inverting voltage amplifiers. The inverting voltage amplifier is a very popular amplifier. It displays most of the characteristics of the non-inverting amplifier except the extremely high input impedance. In addition, at low gains, it will have a smaller gain bandwidth product. This was the circuit diagram of the non-inverting voltage amplifiers. Because here we had applied the input signal to the non-inverting terminal of the op-amp. Now we will make some changes in this circuit and we will make inverting voltage amplifier. So in inverting voltage amplifier we will apply the input signal to the inverting terminal of the op-amp. As I have told you that this terminal is actually the inverting terminal, the inverting input terminal of the op-amp, whereas the positive sign indicates the non-inverting terminal of the op-amp. So for the inverting amplifiers we need op-amp, we need the input signal, and we need the negative feedback. I have told you that RF and RI/RR1 actually provides the negative feedback. These two pins are actually used for the supply voltages, whereas pin number 1 and pin number 5 are used for the input offset voltages, and we will not use these two pins, whereas pin number 6 is the output pin. Pin number 2, pin number 3, these are the input pins. Pin number 6 is the output pin. Pin number 4 and pin number 7, these are the pins which are used for the supply voltages, and 1 and 5, these are used for the input offset voltages. So here we will make some changes in this circuit diagram and we will make it as inverting voltage amplifier. तो हम changes किस तरह करेंगे कि जो हमारा इनपुट सिग्नल है वो हम इन्वर्टिंग टर्मिनल को अप्लाई करेंगे और जो हमारा नॉन इन्वर्टिंग टर्मिनल है उसको ग्राउंड कर लेंगे. तो सबसे पहले मैं ये रिमूव कर लेता हूँ. जो हमारा ग्राउंड टर्मिनल है नॉन इन्वर्टिंग टर्मिनल को, जो हमारा नॉन इन्वर्टिंग टर्मिनल है उसको ग्राउंड कर लेते हैं और जो हमारा इनपुट सिग्नल है उसको सप्लाई इनपुट सप्लाई वोल्टेज अप्लाई करते हैं. सो जो हमारा नॉन इन्वर्टिंग टर्मिनल है उसको हमने ग्राउंड कर लिया और जो हमारा इन्वर्टिंग टर्मिनल है, इन्वर्टिंग इनपुट टर्मिनल, उसको हमने सप्लाई वोल्टेज अप्लाई कर लिया, इनपुट वोल्टेज अप्लाई कर लिया. So now this circuit actually became the circuit diagram of the inverting voltage amplifier. A channel is used for the output. We will use B channel for the input. We will use B channel for the input. Now if I run this circuit, our input voltage is 200 volts, 200 millivolts peak to peak. RF resistor is actually 2 kilo ohm. R1 resistor is actually 1 kilo ohm. Let's make this resistor 1 kilo ohm. First let's make this resistor 1 kilo ohm. Now as we know that in case of the inverting voltage amplifier, what is actually the voltage gain? The voltage gain will be equal to minus RF by RI or R1. In this case जो हमारा RF है वो 1 किलो ओम है और R1 जो है वो भी 1 किलो ओम। तो जो हमारा वोल्टेज गेन है that will be actually equal to -1. The negative sign indicates that there will be 180-degree phase shift between the input and the output signal. और जो हमारा gain है that is equal to -1. It means that the input signal will be exactly equal to the output signal. So let's run this circuit. First let me change the color of the output signal. The color of the output signal is blue. Now run the circuit. I think I didn't apply. It. The color of the output signal is blue. Apply. Okay. Now let's run the circuit. The input voltage is exactly equal to the output voltage. The input voltage is exactly equal to output voltage. If I make it having 180-degree phase shift, जो हमारा gain है that is equal to -1, so the output voltage is equal to the gain into the input voltage. तो जो हमारा gain है that is equal to -1, so the input voltage is exactly equal to the output voltage having 180-degree phase shift. Now let's change the value of RF. Let's make it 2 kilo ohm and run the circuit. Now what will be the gain? If this is 2 kilo ohm, our gain will be -2. So the output voltage will be 2 times the input voltage. The output voltage is 2 times the input voltage because the blue signal actually indicates the output voltage. So the output voltage is 2 times the input voltage. Let's make RF 3 kilo ohm. Now the output voltage will be 3 times the input voltage. The output voltage is actually 3 times the input voltage. Now let me clear it. Now let me clear one thing. How can or how much we can increase the value of RF? If the gain of the op-amp is greater than the supply voltage, our output voltage will be clipped off. It means that if the gain into the input voltage is greater than the supply voltage, here in this case the supply voltage is 15 volts, so the gain into the input voltage is actually the output voltage. So if the output voltage is greater than the supply voltage, the output voltage will be clipped at 15 volts. हम ये कह सकते हैं कि अगर जो हमारा इनपुट वोल्टेज है that is 5 volts and let's suppose the gain is 10. So 10 into 5. 10 into 5. So the output voltage will be 50 volts. But अगर हम इसको ऑसिलोस्कोप पे देखते हैं तो जो हमारा आउटपुट वोल्टेज है वो 15 वोल्ट्स पे क्लिप करेगा, 15 वोल्ट्स पे सेचुरेट करेगा। सही है। तो जब भी हम मतलब इन्वर्टिंग या नॉन इन्वर्टिंग एम्पलीफायर डिजाइन करते हैं तो हम सेचुरेशन को लाजमी देखते हैं कि जो हमारा आउटपुट वोल्टेज है वो सेचुरेट ना हो। इन दिस एग्जांपल जो हमारा इनपुट वोल्टेज है, in this example that is actually 100 millivolts peak or 200 millivolts peak to peak. Now if the input voltage is 10 volts peak to peak, if the input voltage is 10 volts peak to peak and if the value of RF is 5 ohm or 3 ohm, if the value of RF is 3 kilo ohm, so our gain will be minus 3. Our gain will be minus 3, and if the input voltage is 10 volts peak to peak, so how much will be our output voltage? Our output voltage will be minus 3 into 10. Our output voltage will be minus 30 volts peak to peak. Now this voltage is actually greater than the supply voltage. This voltage is actually greater than the supply voltage, that is 15 and minus 15 volts. So if this voltage is greater than supply voltage, so our output voltage will be clipped at 15 volts. Our output voltage will get saturated. So whenever we design the inverting or non-inverting amplifier, we should look at the saturation point. We should not cross this saturation point. It means that now if our gain is 4, so the output voltage will be minus 40 volts, that is minus 40 volts peak to peak or 20 volts peak. So if our output voltage is 20 volts peak, that is greater than 15 volts, our output voltage will get clipped at 15 volts because our output voltage will get saturated. So whenever we design the inverting or non-inverting amplifiers, we must look at the saturation point. So this was all about the inverting voltage amplifier. We are using the op-amp. We can design the inverting or non-inverting voltage amplifier using op-amps and a negative feedback. So whenever we design the non-inverting amplifier, we will apply the input signal to the non-inverting terminal. This 3 indicates the non-inverting terminal, whereas this 2 indicates the inverting terminal. If you have any question, you can ask. Thank you.